Solve x plus 3 over x minus 1 is less than or equal to 2. I'm going to start by manipulating this into an inequality less than or equal to 0. So x plus 3 over x minus 1, take 2, is less than or equal to 0. Combine this into a single rational function, x plus 3 over x minus 1, take 2 lots of x minus 1 over x minus 1 to get my common denominator. And then I've got x minus 2x, so that's minus x. 3 minus 2, so that's plus 5, over x minus 1 is less than or equal to 0. So this is now the inequality I'm going to be solving. Now for this to be negative, I've got two possibilities, either positive over negative or negative over positive. I need to be a little bit careful because the denominator cannot be 0, because the denominator of a fraction can never be 0. So my two possible cases here for this to be true would be if minus x plus 5 is greater than or equal to 0, and x minus 1 is less than 0. Now notice this one has the equal to 0 possibility, because if the numerator is equal to 0, it can be equal to 0, but the denominator cannot be equal to 0. So if these two are true, that means that x is less than or equal to 5, and x is less than 1. Now for both of these things to be true, x to be less than or equal to 5 and x to be less than 1, that just means x is less than 1. So that would be part of our solution. Let's see if there's any more to this solution. We could also have the case where minus x plus 5 is less than or equal to 0. But that means if that is negative, then the denominator, x minus 1, is going to have to be positive. Solving these two inequalities, we're going to get x is greater than or equal to 5 and x is greater than 1. Now, in this case, for both of these to be true, we have to have x is greater than or equal to 5. So the solutions to this inequality are when x is less than 1 or when x is greater than or equal to 5. Two separate parts of the graph are going to satisfy this particular inequality. Looking at this graphically, the graph of the original function x plus 3 over x minus 1 looks like this. And we want to know when this is less than or equal to 2. So when is it below that line? We can see there are two parts of the graph. There is either the part on the right-hand side of this point here, which is when x is greater than or equal to 5. It includes that point where it's equal to 2. But it's also this whole branch over here, so that's everything to the left of the vertical asymptote. And the vertical asymptote is x equals 1. So everything to the left of that is x is less than 1, but not including 1, because this is an asymptote, so it can never actually be equal to 1. So that's what visually why this one is going to be less than, and this one is going to be greater than or equal to when we're writing those final inequalities.